Number 57 is asking us to come up with an estimate here for the square root of 16.2, and they told you two things right here that they told you in this section of problems. They gave you f of x and they gave you the a value. Two things they didn't tell you in the later section of problems, and I'm hoping once you work those, you guys would have been okay at guessing what was going on right here. And knowing what function we needed to use, you can tell this is a square root function right here, and then what a value we needed, something close to 16.2 that's easy to evaluate the square root of, so 16 would have been the only real choice there. Okay, so what do we need to find, guys? Linearization is just telling us to come up with the equation of the tangent line. So I'm going to do, and the order in which you do this doesn't matter here, I'm going to go ahead and evaluate this function at 16 first, and the square root of 16 is just going to get us 4. So we're dealing with the ordered pair 16, 4, for our point of tangency. Then we need our derivative. So f prime of x, the derivative of square root of x, is going to be 1 over 2 root x. And then from there, we'll go ahead and evaluate f prime at this a value of 16. So that square root of 16 is going to become a 4 times 2 is 8. So we're going to get a 1/8 there, and that is going to be the slope of our tangent. So with the two things that I've double underlined here, we have our point of tangency and the slope of our tangent, so we can go ahead to point slope form and then work on solving for y. So we're going to have y minus your y coordinate, 4, equals the slope of your tangent, 1/8 times x minus your x coordinate, which is 16. We're going to bring that 4 to the other side. I'm going to distribute the 1/8. I think we can do two things at once here, guys. So we're going to get y equals, distributing the 1/8 will get me a 1/8 x, and then it would have been from this times this number here, a minus 2, but then we would add 4 to that and get a plus 2 at the end. And just to save a little time, remember that with linearization, we usually like to rewrite that instead of y as L of x. So that's what we have for the linearization. That is the equation of the tangent line to this curve right here at this spot where a is equal to 16. And now the real fun part here, guys. We're trying to come up with an estimate of the square root of 16.2. So what that really is would be f of 16.2, which is approximately equal to or relatively close to L of 16.2. This is the whole point of linearization. So we're going to put that 16.2 into this function right here for x. So 1/8 times that decimal of 16.2 and a plus 2. And let me scroll here just a little bit here, guys. I'll see if I can move that up. All right, so is this something we can do without a calculator? I wouldn't ask you guys to do this on a quiz or a test by hand, but I think I can. 1/8 of 16 is going to be a 2, and then let's see, guys, that's a 0.2 divided by 8 right there, so that ends up being, oh, is that 0.025 right there? Okay, I don't want to screw that up. And I don't have a calculator handy. Great, Mr. Fontana. All right. Sorry, guys, I'm stalling here. All right. So what do we have here? So basically, it's 16.2 divided by 8, and yeah, that was 2.025. There we go, plus the 2 at the end, and that's going to get us our final answer here of 4.025. So that's our approximation then, guys, that the square root of 16.2, and now if I'm writing it this way, I should make that is approximately equal to 4.025. There was a second part of this problem here, guys, that asked you to come up, figure if it was too high or too large. We're not worried about anything like that this year, so we're going to say that that's our final answer and be done with this problem here.